Hello students, I am Dhirendra Shah. Today I will teach you optics for class 10th and the topic is refraction through a glass prism. First of all, we will know what is a prism. You might have seen prism. A prism is a wedge shaped portion of a transparent material. Okay, let me draw the diagram of a glass prism. I'm talking about glass prism. Prism may be made of some other metals also for different purpose. Here we are going to study about the refraction of light through a glass prism. A glass prism basically is made of crown glass or flint glass. So these are the two types of glasses. ये दो तरह के कांच हैं जिससे ये प्रिज्म बना हुआ है. Okay, this angle is the angle of prism. Now let me draw the big picture of glass prism. This is a prism and this angle is the angle of prism. Here take a point and draw a normal. A normal is a perpendicular line. This is the normal. This angle is 90, 90, 90, 90. And take an incident ray. This is an incident ray. If there would be no prism, अगर यहाँ prism नहीं होता तो ये रे सीधे जाता. लेकिन यहाँ prism है. मान लेते हैं prism का जो refractive index है वो है mu. तो अभी लाइट जा रही है हवा से कांच में from air to glass और यहाँ पर हमने एक नॉर्मल ड्रॉ किया है at point P. NP is a normal and OP is an incident ray. This angle is called the incident angle or the angle of incidence. So this light goes from air to glass. There will be refraction. The speed of light will change. This is the refracted ray. PQ is the refracted ray. Again we draw a normal at point Q. This is another normal and S. This is Q. This point is Q. What we see when light goes from rarer to denser medium, it bends towards the normal. OP is the incident ray, PQ is the refracted ray, and QS is the emergent ray. This is an emergent ray, and this angle is the emergent angle. So I will repeat again. What are the name of these rays? OP is the incident ray, PQ is the refracted ray, and QS is the emergent ray. So these are the various rays which we have already indicated here in the diagram of a glass prism for the refraction of light. Now this angle is the angle of prism. Now see what happens. This emergent ray is deviated from its original path. This was the original path and now it is deviated. This angle is the angle of deviation. So A is the angle of prism, delta is the angle of deviation, I is the incident angle or the angle of incident, and E is the emergent angle. This is the angle of prism, this is the incident angle, this is the emergent angle, and this is the angle of deviation, because from this point the light ray is deviated from its original path. And there is a relation among these all angles when you will perform an experiment for the refraction through a glass prism. You will prove that the angle of prism plus angle of deviation equal to incident angle plus emergent angle. So this is the relation among angle of prism, angle of deviation, incident angle and emergent angle. A plus delta equal to I plus E. Again I am repeating, A is the angle of prism, delta is the angle of deviation. Sometimes it is denoted by D also. You can also denote this D, delta by D, and I is the incident angle and E is the emergent angle. So this is the relation between A delta I and E. So we have the two relations. One is A plus delta equal to I plus E, and the refractive index of the prism material mu equal to sine A plus delta m by 2 divided by sine A by 2. This delta m is the minimum deviation. So this relation is derived, but in fact this is not in your 10th syllabus. So I will not derive it, but you have to know this relation because we will use this relation to further study. So what is this delta m? When we plot a graph between the angle of incident I and angle of deviation delta, we get this like graph, U-shaped graph. This point is the minimum deviation delta m, and here we see that I is equal to E. So when the incident angle becomes equal to the emergent angle, at that point, at that case, the angle of deviation is called the minimum deviation. And when we plot a graph, we get such type of graph. And this angle is the angle of minimum deviation. Right? Okay, let us move further ahead. So we have these two relations, a plus delta equal to I plus E, mu equal to sine A plus delta m by 2 upon sine A by 2. We know that for theta tends to 0, sine theta is approximately equal to theta. Means for a small angle, if this angle is very small, sine of this angle will be this angle. So when theta tends to 0, not equal to 0, it is near to 0, it is very, very small, theta is very small. So this whole thing is a plus delta m by 2 is theta, and for a small angle prism, sine theta equal to theta. So we will write here mu equal to sine A plus delta by 2. We will not again repeat here delta m because this is an special case. So we will write here sine A plus delta by 2 divided by A by 2. And this will be equal to A plus delta by 2 into 2 by A. 2 is cancelled. This implies mu equal to A plus delta upon A. I am writing here mu A equal to A plus delta, or delta equal to mu A minus 1. So this is the relation between the angle of deviation, angle of prism, and the refractive index of the prism material. Okay. So the next topic is dispersion of white light through a glass prism. So this relation is very important. So I will write here delta equal to, this is the angle of deviation, delta equal to mu into A minus 1. We will use this relation for further study. Now the next topic is dispersion of white light through a glass prism. You should know that the color of the light is black itself, and we have written here white light. White light. Where is the source of white light? Sunlight is a white light. And there is another source of white light in lab, the mercury vapor lamp and sodium vapor lamp. These are the two vapor lamps from where we get the white light. Let us see what happens when a white light is passed through a glass prism. This is a glass prism. This is the angle of prism. And take an incident ray. This is the white light. White ray of light. This is a slit. A slit is a narrow opening through which light can pass. The width of the slit can be adjusted. So first we allow the white light to pass through the slit, and then it is incident on the one face of the glass prism. This will suffer first refraction, and then it will come out from the prism. So this is the violet color of the white light. Violet, indigo, blue, green, yellow, orange, and red. Okay, what we see, when white light is passed through a glass prism, it is splitted into 7 component colors. White light is made of 7 colors with pure. Violet, V means violet. I am not writing again, I am reciting only. V means violet, I means indigo, B means blue, G means green, Y means yellow, O means orange, and R means red. So this is with pure. This is the band of 7 colors obtained on the screen. This is known as the spectrum. This band of 7 color obtained on the screen is called spectrum. So what we observe here, the violet color suffers very large deviation. Let me write here. So before we discuss some other phenomena, we will start from one fact. What is the dispersion of light? So let us see. When a white ray of light is passed through a glass prism, it is splitted into 7 component colors. The phenomena of the splitting of white light into 7 component colors when passed through a glass prism is called dispersion of light. Right? So dispersion of light is what? The splitting of white light when passed through a glass prism into 7 component colors. The phenomena of the dispersion is the splitting of white light into 7 component colors when passed through a glass prism. The different colors suffers different deviations or angle of deviations. Right? So let me write here, the deviation for the violet color is more and the deviation of the red color is less. Red color deviates less. Deviation of red is less, but the deviation of violet is more. Different colors deviates by different angle of deviations. We know that the wavelength of the red color, wavelength is denoted by lambda. Wavelength of red color is more than the wavelength of violet color. Right? And there is one relation to explain the phenomena of dispersion of white light. The cause for the dispersion of white light when the white light is passed through glass prism is explained well by Cauchy relation. Cauchy's relation. What is Cauchy relation? The refractive index of the prism material mu equal to A plus B upon lambda square plus C upon lambda 4 plus dot dot dot. Again I am repeating Cauchy relation. Mu is the refractive index of the glass prism. The refractive index of the glass prism will depend on the wavelength of light used. Right? Consequently, we draw a conclusion from this relation, Cauchy relation, which will explain the phenomena of dispersion of white light. So what we see here, we see that mu is inversely proportional to lambda square. Mu is inversely proportional to lambda square. A, B, C are constant. If the wavelength of the color is more, the refractive index of the glass prism will be less. So for the red color of light, for this color, red color, the refractive index of the prism material becomes less. So for the different component colors, the refractive index of the prism material is different. समझ में प्रिज्म के रिफ्रैक्टिव इंडेक्स, प्रिज्म के मटेरियल का जो रिफ्रैक्टिव इंडेक्स है वो अलग अलग है, अलग अलग हो जाता है जब अलग अलग रंगों वाली प्रकाश उससे जाती है. जब रेड कलर पास होगी, क्योंकि रेड कलर का वेवलेंथ ज्यादा है, तभी तो रेड कलर का यूज खतरे के सिग्नल के लिए होता है. रेड लाइट से निकलने वाली जो लाइट है उसका वेवलेंथ ज्यादा होने से हम उसको जल्दी देख पाते हैं. तो रेड कलर का वेवलेंथ ज्यादा है तो उसमें प्रिज्म के मटेरियल का रिफ्रैक्टिव इंडेक्स है वो कम हो जाएगा. जब रिफ्रैक्टिव इंडेक्स कम होगा, आइए इस रिलेशन को यूज करते हैं हम लोग. जब रिफ्रैक्टिव इंडेक्स कम होगा ये वही रिलेशन है, मैंने लिखा था पहले इसको, डेल्टा इक्वल टू म्यू ए माइनस 1। तो म्यू अगर कम होगा तो डेल्टा भी कम होगा। मतलब क्या है, जो रेड कलर है वो कम डेविएट होगा। मैं फिर से बता रहा हूं आपको, रेड कलर का जो वेवलेंथ है वो सबसे ज्यादा है, देख लीजिए, रेड कलर का वेवलेंथ सबसे ज्यादा है। तो रेड कलर का वेवलेंथ ज्यादा है तो उसमें प्रिज्म के मटेरियल का रिफ्रैक्टिव इंडेक्स कम होगा। जब कम होगा तो डेविएशन भी कम होगा रेड कलर का। यहां तो मैंने लिखा है द डेविएशन ऑफ रेड कलर इज लेस देन द एंड द डेविएशन ऑफ वायलेट कलर इज मोर। सो दिस इज द एक्सप्लेनेशन ऑफ द डेविएशन ऑफ डिस्पर्सन ऑफ व्हाइट लाइट। कॉची ने एक्सप्लेन किया कि व्हाट इज द कॉज फॉर द डिस्पर्सन ऑफ लाइट, because the different colors has different wavelengths when it passes through a glass prism, and for the different wavelengths the refractive index of the prism material is different. When the refractive index of the prism material is different, the colors, 7 colors, deviates by different angles. For the angle of deviation for the 7 component colors are different. So we can write here, again we have written here the two results. So these are well explained here from this Cauchy relation and from this relation also, the relation between the angle of deviation, refractive index and the angle of prism. Angle of prism is constant, it is not changing, ये बदल नहीं रहा। ठीक है, तो यहां पर हम लिख सकते हैं, क्या लिख सकते हैं कि रिफ्रैक्टिव इंडेक्स म्यू इज लेस फॉर रेड कलर, म्यू इज फॉर रेड कलर इज लेस देन द म्यू फॉर वायलेट कलर। क्यों होगा भाई, कि रेड कलर का जो डेविएशन है वो कम है। क्यों है, क्योंकि जब रेड कलर पास होगी तो रेड कलर का वेवलेंथ ज्यादा है तो रिफ्रैक्टिव इंडेक्स कम है, रिफ्रैक्टिव इंडेक्स कम है तो डेविएशन भी कम है। जब ठीक है तो रिफ्रैक्टिव इंडेक्स रेड कलर के लिए कम है क्योंकि वेवलेंथ ज्यादा है, रिफ्रैक्टिव इंडेक्स कम है। वायलेट का रिफ्रैक्टिव इंडेक्स, वायलेट कलर का वेवलेंथ कम है, वायलेट कलर का वेवलेंथ कम है तो रिफ्रैक्टिव इंडेक्स ज्यादा होगा। जब रिफ्रैक्टिव इंडेक्स ज्यादा होगा तो डेविएशन भी ज्यादा होगा। इसलिए डेविएशन फॉर द वायलेट कलर इज मोर एंड द डेविएशन ऑफ द रेड कलर इज लेस। द वेवलेंथ ऑफ द रेड कलर इज मोर, द वेवलेंथ ऑफ द वायलेट कलर इज मोर लेस, एंड द refractive index of the prism material for the red color is less than the refractive index of the prism material for the violet color. It is more. अब एक थोड़ा सा एक एडवांस लेवल का क्वेश्चन है कि आप एक एक्सपेरिमेंट कर रहे हो। सपोज यू आर फाइंडिंग द फोकल लेंथ ऑफ कॉन्वेक्स लेंस। आपको कॉन्वेक्स लेंस बाय कॉन्वेक्स लेंस दिया गया है और आपको कहा गया आप इसका फोकल लेंथ निकालिए। And the condition is you are using the violet light यूज कर रहे हो। आप प्रिज्म के मटेरियल का, आप ग्लास ये लेंस का रिफ्रैक्टिव इंडेक्स निकाल रहे हो और आपको कहा गया है कि आप रेड कलर का लाइट यूज कीजिएगा। अगर रेड कलर का लाइट यूज कर रहे हो और जो रिफ्रैक्टिव इंडेक्स जो आपने फोकल लेंथ निकाला प्रिज्म उसका लेंस का, अगर हम कलर बदल दे, अगर रेड कलर यूज कर रहे हो उसके जगह अगर वायलेट कलर का यूज करोगे तो क्या फोकल लेंथ चेंज होगा? अगर होगा तो ज्यादा होगा या कम होगा, ये नेक्स्ट सेशन में हम आपसे डिस्कस करेंगे। आज इतना रखते हैं। थैंक यू वेरी मच।